Hello everyone, this is Amika Mahajan. Welcome to my channel. Watch this video till end. If you find contents of this video to be useful, then like it, share it and subscribe to my channel. Zoom into Physics class by Ms. Amika Mahajan. In this video, I will discuss electromagnetic waves for class 12. I will focus on which property of electromagnetic waves is responsible for great use in communication. How can we prove that electromagnetic waves, they carry energy and momentum? How is the energy propagated in an electromagnetic wave? How is the energy carried by electromagnetic waves distributed between electric and magnetic fields? When sun shines on our hands do not feel being pressed down. Why? Before discussing these facts, let's recall some properties of electromagnetic waves. Electromagnetic waves do not require any material medium for their propagation. They travel in free space with speed of light. As medium changes, speed also changes. Electromagnetic waves are transverse in nature. Electric and magnetic field vectors oscillate perpendicular to each other as well as perpendicular to direction of propagation of wave in electromagnetic wave. And at any time t, the ratio of amplitude of electric field and magnetic field gives value of speed of light. Which property find great use of electromagnetic waves in communication? The property is that the electromagnetic waves carry energy. Marconi is known to be father of wireless communication. Now, how can we prove that electromagnetic waves carry energy and momentum? Because energy is being transferred in the form of electric and magnetic field oscillations. So, the energy of electric and magnetic field is transferred to charged particles if these are present in a plane perpendicular to direction of propagation of wave. As a result of which, these particles start oscillating or they come in motion. So, they are acquiring energy and momentum from the waves from electric and magnetic fields of electromagnetic wave. Also, when sun shines on our hands get warmed. It is also due to energy transferred by sun to our hands. As energy is carried by waves, therefore momentum is also carried by waves. Because electromagnetic wave carry momentum. So electromagnetic wave also exerts pressure, which is known as radiation pressure. And pressure is given by force upon area. Rate of change of momentum is equal to force. If total energy U is transferred to the surface in time t, and we consider this energy absorption to be complete without any loss, then momentum transfer to the surface is given by energy U divided by speed of light c. As speed of light is very large, as a result of which momentum transfer will be least to the surface. Because momentum transferred is least, therefore pressure exerted on the surface will also be least. That is why when sun shines on our hands, what happens? Our hands do not feel any pressure. Basically, electromagnetic waves, they are carrying energy by means of electric and magnetic field vectors. Although electric and magnetic field, they are oscillating perpendicular to direction of propagation of wave. But energy propagated by means of those fields is always in the direction of propagation of wave. And this energy is equally distributed between electric and magnetic fields. We can prove this by proving electric energy density to be equal to magnetic energy density. Already we have done in electrostatics that in a region of free space with electric field E, electric energy density is given by half epsilon naught E square. Speed of light is 1 by square root of epsilon naught mu naught. So by taking square on both sides of this term and getting epsilon naught, also E by B is C, that means amplitude of electric field and magnetic field, its ratio is speed of light. Putting these values in this equation, half epsilon naught E square, I get half B square by mu naught. And this term is equal to magnetic energy density. So we have proved that electric energy density is equal to magnetic energy density. That means energy carried by electromagnetic waves is distributed equally between electric and magnetic fields. Other properties of electromagnetic waves. The nature of electromagnetic waves is governed by their frequency. There are so many components of electromagnetic waves in electromagnetic spectrum. Each wave has its own frequency. So nature of electromagnetic waves is governed by the frequency and they obey superposition principle. Matter also emits electromagnetic waves, but in the form of certain quantas of energy, which is known as photon. Electromagnetic waves are neutral. So these are not deflected by electric and magnetic fields. Light or other electromagnetic radiation from many sources like sun, flames, incandescent lamp. It is unpolarized in nature. And electromagnetic waves, they show properties of wave. They show reflection, refraction, interference, diffraction, and polarization. Electromagnetic waves, they also interact with matter, but through their electric and magnetic fields. What happens? These electric and magnetic field oscillations, they set all the charges present in all matter in oscillations when come in contact with electromagnetic waves. The interaction and mechanism of absorption and scattering, etc., depend upon wavelength of the electromagnetic wave. Also, it depends upon nature of atoms and molecules in the medium. So in this video, what we have discussed that electromagnetic waves, they carry energy and momentum. Because they carry energy, so they are very useful in the field of communication. In electromagnetic wave, the energy is propagated by means of electric and magnetic field vectors, but energy is carried in the direction of propagation of wave, although electric and magnetic field oscillation take place perpendicular to direction of propagation of wave, but energy is always propagated in the direction of propagation of wave. Energy carried by electromagnetic waves is equally distributed between electric and magnetic fields. Electromagnetic wave also exerts pressure, but this pressure is least. Electromagnetic waves are neutral, so these are not deflected by electric and magnetic fields. They show properties of reflection, refraction, interference, diffraction, and polarization. Thank you all for watching this video. You can post your queries to our email address given in the slide, and also you can put your comments in comment sections. If you find this video to be useful, then like it, share it, and subscribe to my channel Zoom into Physics by Miss Amika Mahajan. Thank you.